Friction is an essential factor that determines the grip of a shoe on a surface. When we walk or run, our shoes make contact with the ground, and friction between the sole of the shoe and the ground helps us maintain our balance and stability. The amount of friction between the shoe and the ground is determined by the coefficient of friction, which is the measure of the force required to move one surface over another.
Our goal was to examine different types of shoes under wet and dry conditions to see which ones had the most traction under each condition. We wanted to conduct this experiment because there's so many different shoes with different purposes, and we want to know which shoes are better under wet and dry conditions to not slip and prevent injury. We measured this traction through the coefficient of static friction. In our experiment, we would find the tension force, or the force required to make the shoe move, and use that to calculate the coefficient of static friction.
To conduct this experiment, we set up a ramp on a stand and placed the shoe on the ramp. Inside each shoe, we placed 5-kilogram weights to increase the normal force of the shoe and make it more realistic to a person wearing the shoe. For the wet ramp trial, we used a wet paper towel before each trial and wiped the water up and down twice. Then we tied a string around the middle of the shoe and attached it to a force monitor. To collect our data, we used the force sensor and the capstone application to track the data of each trial.
Firstly, it's beneficial to remind ourselves how we can measure friction in this specific experiment. We decided to only pay attention to the static coefficient of friction because that is what keeps our shoes from initially losing traction, causing us to slip and fall. We used the traditional equation to find the static coefficient of friction, US equals F over N. In our case, the force is tension from the string, which we can measure using the force probe. The normal force stayed constant for each trial. Our experiment yielded results that had the boot with the largest coefficient of static friction, followed by the Converse shoe, and then the Croc. The order of this stayed the same for the wet and dry ramp, but the wet ramp made all three shoes have a lower overall coefficient of static friction. This means that all three of the shoes were easier to slip when the ramp surface was wet.